is easy to predict because basically what you're going to have is a situation where the metals switch places. Okay, so here you have Princess Peach and can't remember her name, Buttercup or whatever, and then Luigi and Mario, and then Mario ends up with Peach, and Luigi ends up with Daisy. I think it's Daisy. Okay. Um, so we're looking for a situation like that. When you're trying to identify these, you'll have compounds at both sides. Here it is in sort of slow motion instant replay. You have your potassium with the um, chloride. The chloride goes to the silver, and then the nitrate goes from the silver to the potassium. All right. So when we're doing these, we're going to need to again keep these charges in mind. So calcium is +2, lithium is +1. All right. Why do we know that? Because it's right here. Calcium is +2, and lithium is +1. And then we're going to need our polyatomics as well. Polyatomic wise, we're looking at a nitrate, which is a -1. And we're looking at our chloride and a carbonate, not even a nitrate. So we're looking at a carbonate, which is -2, and chloride. So carbonate is -2, and then the chloride is right here, is -1. All right. So step one, just like with single replacement, we want to switch those metals around and figure out what our products are. So the lithium is going to be with the carbonate, and the lithium is going to be with the chloride, and the calcium is going to be with the carbonate. And now we have to manipulate our subscripts to make these things actually what they are. So lithium being +1 and chlorine being -1, neutralizing that charge, you only need one of each. So chlorine is losing its 2 to become a 1 because when it forms a compound with lithium, it only needs 1. Carbonate is keeping its 3 because it's one of those polyatomics, right? Carbonate is one of these things. So it's the whole thing you have to take with that charge. And since it's -2 and each calcium's +2, you only need 1 to 1. So these are the products. Now that we have our products established, we balance with a coefficient. So there's 2 lithiums here, there's only 1 there, so we need a 2 there. There's 2 chlorines here, there's only now 2 there, 1 carbonate, 1 calcium. All right, let's try this again. Sodium and barium are going to switch places. All right, barium is +2 and sodium is +1. So it's going to take 2 sodiums to replace that barium, right? So the situation will be, um, well, barium can replace 2 sodiums, I guess. So barium is going to get with the sulfate, and sodium is going to get, it's supposed to be a plus, with the chlorine. So sodium is +1, chlorine is -1. So a 1-to-1 situation works fine to neutralize the charge to 0. So that's fine. Barium is +2, sulfate is -2. Sulfate is -2. And since it's -2, it will take a 1-to-1 situation with barium to neutralize. So that's good. So that our products have the coefficients set up where they can be successful now. Everything is neutralized. Now we need to put up our subscripts rather are all good. Now we need to put up our coefficients. There's 2 sodiums here. There's only 1 there, so we need a 2 there. There's 2 chlorines here. Now there's 2 chlorines. There's 1 barium and 1 sulfate, so that works. All right, with HCl and acid, uh, going with a base, sodium hydroxide, acids have leading H's, and leading H's kind of act like metals. So a +1, that's sort of what that's doing, and it's going to switch around with the sodium. So they're both going to be +1. The hydroxide is -1. The chloride is -1. Chloride's -1 because it's here. Hydroxide's -1 because it's here as a -1. So if we're doing that, the hydrogen now gets with the OH, and the sodium gets with the chloride. Everything was 1 1, everything's good. There's no balancing to do, so that makes water and sodium chloride. So when you mix an acid with a base, you get water. All right, so this last one, we're going to mix lead with potassium. Now, lead is one of those unknowns. So, but the potassium we know as +1. So the potassium we know is +1. The lead we don't know, but we're going to use that nitrate to figure it out. So that nitrate has a charge of -1. And since there's two of them, since there's two nitrates, that means the lead must be a +2 charge because two -1s had to neutralize it. Potassium is +1. The dichromate, whoops, right here, dichromate is -2. So Cr2O7 is -2. So that's why it took two potassiums to knock that out to make it 0. All right, so we're going to switch our places. So now the lead is with the dichromate, and the potassium is with the NO3. So if this is +2 and this is -2, you only need one of each to neutralize. If this is +1 and this is -1, you only need one of each to neutralize. So we're done with subscripts. We kept the subscripts here because it's a polyatomic. We kept the subscripts there because it's a polyatomic. We dropped that subscript because we didn't need two of them to neutralize the potassium. Now we can start doing balancing. There's two potassiums here. There's only one there, so we need a 2. There's one lead, one dichromate, two nitrates, two nitrates. So the balancing on these is actually pretty easy.